Hello everyone. This is Friday of Weather Week and we're going to wrap some things up today. Thought I'd share an idea with you. This is something I used to do in my classroom when I was teaching weather to junior high students. We would have a daily weather board that we would fill out. That way we could keep track of what the weather was going to be that day. And then we took all of those days and we put it together to see how the weather changed throughout that entire 2 or 3 weeks that we did that. I want to first start off by giving a big shout out to Johnny Man of Johnny Man Weather. I had a chance to see his weather forecast one day last week and it was really cool. He's got a really neat setup with a weather station and he takes all of this information down and then shares it on his video. So way to go, Johnny Man, keep up the great work. So let's talk about today's weather. So today, Friday, March 5th, our forecast is sunny. So we have these different little things that we can put up here if it's cloudy or thunderstorms or rainy or partly cloudy. And we don't want to get this one out anymore. This one says snow. So our temperature for today started off a low of 29, which is pretty cold. We have to have our jackets on and our stocking caps. And then it's going to get all the way up to 49 degrees. And since it's going to be sunny and the winds aren't going to be very hard or very strong, then it's going to be pretty comfortable. Now these other measurements of humidity, pressure, and UV index, we're going to talk a little bit more about here in just a few minutes. But I wanted to point out my superheroes because all of you guys are weather superheroes now, like Superman with his sunglasses, Wonder Woman with her umbrella, and of course Captain America with his rain boots and rain hat. So all this week we've been talking about weather and we really haven't had a chance to touch on the tools that meteorologists use. You remember, meteorologist is what a weather scientist is called. So that person that takes all of that information we just showed you on the superhero weather board and puts it into a forecast so that we know what the weather is going to be like today and for the next few days also. So we're going to talk a little bit about some of the different tools that are used. In order to get the temperature, now there's a lot of different kinds of thermometers that we see. But this is just a spring one that has the dial that goes across to tell the different temperatures at different times of the day. So this one is called an anemometer. This measures wind speed and then it also has a wind vane at the bottom. And the way this works is when the wind blows, it causes this little thing here with the cups to spin. And if the wind is blowing faster, then the cups will spin faster. And so that will tell us how fast the wind is blowing. So that's called an anemometer. One of the things that we also especially are aware of during the summer is humidity. And that again is the water vapor in the air. When our air temperature is warmer, it can hold more humidity, more water vapor in the air. And we feel that as being kind of uncomfortable because it doesn't allow our bodies to sweat as easily. And when we sweat, that helps us to stay cool. When there's more water vapor in the air around our skin and around our body because the humidity is higher, then it makes it a little bit more uncomfortable. That's why in the summer we talk about those hot, humid days. Well, we're going to get to those pretty soon. But the higher this number, the humidity, then the higher the percentage of the water vapor in the air, and the more uncomfortable it is. When you get down into the 40s, then it's a pretty low amount of humidity, and it's probably cold then, because cold air doesn't hold as much water vapor, therefore the air is drier. That's why sometimes in the winter we get dry skin, because there's less humidity in the air. So this one is called a barometer. And a barometer measures the air pressure. You remember when we did the demonstration where I put the cup of water with a piece of paper under it and then took my hand off and the water didn't come out? Or when I took the cup and pushed it down into the sink with water and nothing came into the cup? That's because air has pressure. And the specific measurement for air pressure is how much weight this column of air, all this air above my head, has as gravity pulls it down. So it changes depending on different types of weather that we have. When we have high pressure, it's kind of associated with clear and nice days. Low humidity means that the air is a little bit more humid, and we normally associate that with cloudy and sometimes rainy days. So that's another measurement that meteorologists use, and they take those measurements all over the country, and then they determine what the weather is going to be like. And I think we're going to talk about that just a little bit later. So one that you may not be aware of is called the UV, or ultraviolet index. Now, you are aware of the effect of this, but we may not have talked about the actual measurements of this. When we go outside in the summer, we always make sure we have a hat on and sunscreen, or we have long sleeves on so that our skin doesn't get exposed to the sun. Well, the part of the sun that affects our skin is the ultraviolet rays, or ultraviolet radiation. Now, we can't see that because it's invisible, but that energy from the sun can affect our skin by causing our skin to get burned, or that sunburn that we have to try to avoid because that's really, really uncomfortable. And it's not very healthy. So when we had the UV index on the weather board, it was at a 3, which is really low. Now, anytime you're in this yellow area, you don't have to worry too much about sunburn. But when we get to 6 or more, you better have sunscreen on. And if it gets at this 8, 9, or 10, we probably should just stay inside, because that could be really a quick sunburn if we don't have the proper clothes on, or we don't have sunscreen on, and that would really make for a very uncomfortable next few days after you get a sunburn. Now, one of the things that you might find interesting, in order to get the information for a weather board, if you do that in your house, is I like to go to the website for the National Weather Service. Now, you can also use the Weather Channel, which I use all the time when I look at my phone. And we can get all this information, and it's pretty hard to see, but these are all the different things that we put on our weather board. So the wind speed, the temperature, and so on. Now, the reason we do this for day to day is so that we're prepared for what to expect. We need to know whether to wear short sleeves like this when I'm going out to the golf course, or I need to put my jacket or sweatshirt on when it's a little bit colder, and my hat. So I make sure I know what the temperature is. Now, it's also really important to know what the weather is going to be when we get into some more serious weather conditions. And we're going to talk about that just a little bit. One of the important reasons why we study the weather is to make sure that we are prepared when more serious weather conditions are present. Those more serious weather conditions include heavy rain, thunderstorms, lightning, and possibly tornadoes. The National Weather Service, which we've talked about, that gives us all this information about the weather, will send out watches and warnings when the conditions are present for those to form. And so we pay attention to the weather in order to make sure that we understand what changes are going to take place, because it could be sunny outside one minute And then a half an hour, 20, 35 minutes later, the clouds start rolling in and it starts to rain. So we're aware of these kind of things so that we can make sure that we're prepared. The reason we're talking about these is not so that we're going to make you afraid of them. It's quite the opposite. We want you to understand more about these weather conditions so that we know what the plan is to stay safe and we follow directions when those kind of conditions take place. So, like I said, the National Weather Service sends out 2 different levels of alerts. The first alert is what's called a watch. So there could be a thunderstorm watch or a tornado watch. When we hear about that, that means that the conditions are present that these kind of storms could form. Now, when they do get more serious, the storms get more serious, then the National Weather Service could issue a tornado warning. And if that's the case, that means that there has either been a sighting of severe thunderstorms or tornadoes, or that it appears on radar that those conditions are present. So we need to take appropriate actions. Now, those actions are part of this Weather Preparedness Week, which we're wrapping into our weather study here. Also, Annie tells me that Shannon has prepared a video for you, so I'm going to let her talk about weather preparedness kits. And so she'll talk to you guys about that a little bit later. So we have a couple of short videos that we're going to take a look at that shows a thunderstorm developing, because it's really hard to do that, and especially since the sun's shining outside. So we'll show just a couple of little short video clips of that so you can see what it is we're talking about. So in this first short video clip, we're going to take a look at understanding lightning a little bit better. It's really hard to demonstrate lightning unless we do it on a really small scale, which we've all experienced. Have you ever shuffled across the room or had someone else shuffle across the room and then either touch you or you touch a doorknob and you get a little quick zap? Well, that's what static electricity is. And basically, lightning is static electricity, only on a much, much larger scale. So we're going to watch a little bit of this video, and then we'll talk about it briefly.
Lightning is one of the most incredible natural phenomenons, and one that scientists are still learning about. It's a common occurrence during summer, when the heat of the day is broken by strokes of lightning. Worldwide, it's estimated lightning occurs 50 to 100 times a second. The greatest concentrations of lightning strikes are in Central Africa, the Himalayas, and South America. Lightning is often seen flashing between storm clouds in the earth. The bursts of light are pure electricity. Scientists don't fully agree on what actually causes the electrical charge to be dispersed, but it is generally thought that lightning often occurs within the downdrafts and updrafts of thunderstorms. Lighter particles moving toward the top of clouds become positively charged, while heavier particles heading toward the bottom become negatively charged. When the positive and negative charges grow large enough, lightning is released between these regions. Most of the lightning takes place within the cloud, but some strikes the earth in bold flashes. In these cases, the charge escapes the cloud, making a branching path that reaches for the ground. The energy of the lightning strike contains hundreds of millions of volts and lasts only a fraction of a second. What seems to be a single flash is actually a series of return strokes of electrical energy reaching back up into the clouds. The path reaches temperatures of around 50,000 degrees Fahrenheit. This extreme heat creates a booming thunderclap as excessive pressure within the lightning path expands at supersonic rates on return strokes.
Okay, so that gives us a little bit of an idea of what we're talking about with this more serious weather. In a thunderstorm, a lot of times they will have lightning, and then of course, like they just described here, when there's lightning, there's thunder. but we know that we're safe if we're indoors or we're inside the vehicle. So again, making sure that we understand how to stay safe in these serious weather conditions is very important. Another weather condition that we need to be especially aware of, happens most of the time in the springtime, is the formation of tornadoes, which is a whirling wind from the thunderstorm that reaches all the way down to the ground and can cause quite a bit of damage. And so when we know that those conditions exist by knowing what the weather is going to be, and when a warning has been given by the National Weather Service, we know what to do in order to stay safe. And again, that's the purpose of this weather preparedness. All the folks that help take care of you guys know what to do when the weather gets really bad, and they'll do that just to keep you safe. And so we all cooperate, we know what we need to do, we're not going to be real scared. It's okay to be a little frightened, because that's natural, but we do what we have to do in order to stay safe, and then everyone will be okay. So the severe weather that we talked about with the lightning and the thunderstorms and tornadoes, again, are all part of the natural weather that takes place here in the Midwest. And again, the more we understand about it, the more we know how to stay safe, and we make sure that we keep an eye on the sky. So when those kind of things do come along, we are prepared.
Hi, Mr. Gill, the science dude. Welcome back.
Well, thank you. It's good to see you again, Annie.
Yes, thank you so much for all of your weather videos that you did for us this week.
You are welcome. It was a lot of fun.
We appreciate it, and we learned some things. But
What? Name one thing you learned. I'll put you on the spot.
it's just not nice.
That's okay.
I learned about the air pressure with the cup of water. I thought that was really cool, and that there's still air inside your cup when you put it in the water, how the paper towel stayed dry. I really liked that one.
Good. You know, my camera person
Yes.
freaked out when the water splashed. But it was fun.
I could see that.
But I had a dry paper towel to clean it up with from the first time.
There you go. Perfect. All
Yep.
right. Well, we learned lots of things, but we do have a few more questions.
Okay.
And
great.
so I have some pictures to go along with those questions because you have some answers for us, right?
Believe so. Since
All right.
we've already taken a look at them. But
Yeah, we appreciate everybody who sent those to us. It's
Absolutely.
so nice that we have those. All right, I'm going to make
so
it
what's
nice
the first
and big.
question?
Well, our first question is, why is the sky blue?
That is a good question. And that is such a cool question, too.
All
So
right.
if you go to that first picture, all right,
Okay.
so that right there, have you ever seen a prism before? That little
I
triangular
have.
piece of glass?
Well, as
So-
the music person, I see Pink Floyd.
Well, they're not, we can talk about the science of music a little bit later. However, they use that, you're right. So a prism is this triangular piece of glass that if you shine a beam of white light through, the white light gets bent and breaks up into the actual different colors that white light is made out of.
Oh, wow.
So what this picture shows you is that white light actually is made of red, orange, yellow, green, blue, and violet light. When it's all together, it's white.
Okay.
Now, the sun is sending this white light to the earth. And the earth is covered with this atmosphere of gases. And I think if you go to the next picture, it'll help with this part.
Ah, okay.
When the light hits the gas and dust particles in the atmosphere, it causes the light to scatter. Now, since the blue light that makes up all the different color, all of the white part of the white light,
Mhm.
since the blue is a shorter wavelength
it gets scattered more.
Okay.
So when all that blue light is scattering all over the place, that's when we see that blue light in our atmosphere.
So that's cool.
Here's something else that goes along with that. We could ask the same question.
Mm-hmm.
Why is the sea blue?
Because water's clear.
Water, if you have that cup of water in a glass, it is clear.
Yeah.
However, the same kind of thing is taking place where when that white light hits the water,
Mm-hmm.
it scatters and it's absorbed in that upper few layers of the water and is reflected back, and then we see the blue color.
That's cool. All right.
So the sky is blue.
Mm-hmm.
So right now, there is a little rover being driven around by NASA on Mars.
Mm-hmm.
The Mars atmosphere is not like ours.
No.
Therefore, when they look up at the atmosphere on Mars, it has kind of an orange color.
Ooh.
I know. It's really
That's
cool.
Yeah.
All right. So with
Mm-hmm.
with that information, that knowledge, what color would the sunlight be on Mercury?
I didn't know this was going to have a quiz, Mr. Gill.
Well, let me help you with that. There is no atmosphere on Mercury.
So would it be white?
It would be intense white because it's the closest planet to the sun.
Yeah, no thanks.
You wouldn't be able to get SPF 150,000 on to help you there.
No.
Okay. Did that answer that question?
Yeah, it did. Thanks so much.
I love that question.
It's a good one.
All right, what's your next question?
All right. Our next question is, we talked about air pressure,
Mhm.
but how does barometric pressure impact our weather changes?
So barometric pressure is air pressure.
Oh, okay.
We measure air pressure using a device called a barometer.
Okay.
And that barometer measures the weight of a column of air
Mhm.
as if we just take like a big invisible tube,
Uh-huh.
we weigh all that air. That's pressure. That's the air pressure which the barometer is measuring.
Okay.
The barometer, unless you really had a chance to look at what a real mercury barometer looks like, it's kind of hard to figure out how it measures it. But gravity is pulling down on all the air molecules above us. So if there's a whole bunch more air molecules, it pulls them down on us,
Okay.
even heavier. Okay.
Yes.
So if we take some of the heavy molecules out
Mhm.
and we stick lighter ones in there,
Yes.
we have lower pressure.
Makes sense.
Yes, it does. Because if you take a look at that diagram right there,
Okay.
low pressure
Mhm.
is, and the picture over on the right
Okay.
is the one with the cloud.
Yes.
Low pressure is associated with more humid air,
Mm.
cloudy and rainy,
Okay.
and sometimes cooler temperatures, which cause that air to rise up. Humidity in that lower pressure air
Okay.
then condenses and forms that cloud.
All right.
High pressure
Mhm.
is more associated with sunny weather, clear and nice days.
Yeah. So usually high would be higher temperatures too?
No, not necessarily.
Okay.
The really, really, really cold days that we had when the sun is out and it's below zero,
Ugh.
that's high pressure.
Really?
The pressure isn't dependent on the temperature per se. It's dependent on more the humidity.
Got
And
it.
that dry, cold air, which comes down from Canada and freezes our tails off
Yes.
every now and then with these really cold spells that we had, that's associated with clear weather, which is this cold, high pressure air mass.
Okay.
These air masses kind of move along by the trade winds, by the jet stream, and they kind of contain all the weather. The barometric pressure is pretty much equal in there. No, it's not equal. Let me say it differently. It's in a certain range.
Okay.
And then that whole mass moves along. Well, one air mass bumps into another. We get two different factors influencing our weather. If we're underneath the air mass, like this high pressure air mass, it's going to be clear, not very many clouds. But if that air mass then bumps into another one, they form a boundary in between the two of them called a front.
Okay.
And that front, where one air mass is bumping into another, then also has certain weather conditions. We're going to see in the springtime here, which is really important to understand, that when a cold air mass that is usually this higher pressure bumps into a lower air mass, which is warmer air, it forms a cold front. And that's because this cold air mass then moves underneath and pushes the warmer air up. And that's where thunderstorms develop along that cold front.
Okay.
And that's why it's usually kind of clear and calm after a thunderstorm goes through.
Ah, okay. And we learned about how heat rises with your bubble demonstration earlier.
Right.
Yeah, that's helpful. Awesome.
Good.
Did you have another picture to go with this one?
Yes, I believe so.
Oh.
So all around the country, different weather stations, like Johnny Mann's station, if he wanted to report it, they write down the barometric pressure in all these different stations. And then we see where these lines are, the circles, and each of the area that's on that line all has the same barometric pressure.
Okay.
And so that barometric pressure could be higher, could be lower, and then that's where these highs and lows, the H and the L's on a weather map comes from. As all of that moves across the country from west to east, that's how meteorologists predict what the weather is going to be.
Oh.
They don't just move in a straight line, they'll go up. We get weather that comes up from Texas that's usually bringing lots of moisture. Recently, we had that really cold air that came down from Canada.
Okay.
That was clear and cold weather, except for we did have a lot of snow in the last one, which means that it's not exactly high pressure, low pressure means this or this. There are certain conditions within that range still.
Got it. And this little blue thingy, that's, where they're meeting, right? With the blue arrows.
That's right. That is a cold front right there with the blue triangle like that, which we see the green on the map right there.
Yeah.
That is indicating that there is rain present in those areas. So I'm not sure when this map was from, but we can see about almost half of Illinois, the southern half, was experiencing rain that day because that cold front moved through.
Cool.
Yeah.
Very cool. All right. Now we can read weather maps.
That's part of what we need to learn.
Hey. Absolutely. All right. This is our last question, but of course.
And my favorite one.
Your favorite one? Excellent.
Yes.
Why is there springtime?
So spring is one of the 4 seasons. And if my birthday was in the spring, I would be ecstatic because it's going to be great weather. And I love to go out and play golf and go for walks and stuff like that outside when we get to springtime weather.
Yes.
But we also
birthday's in football season though.
Yes, and that's even better. I forgot I know what I was going to say.
Back to spring.
The reason why we're doing this weather week in just before we get to spring is so we understand the weather is going to change an awful lot during the springtime.
Yeah.
As we move from winter to spring, it's because the sun is heating up the earth a little bit more. Now, it's a really long explanation. I'm going to give you the short version.
All right.
Okay. The earth orbits around the sun. when we're orbiting around the sun, the Earth is actually tilted. See how the Earth isn't straight up and down in this picture?
Yeah, this rotation axis?
The rotation axis. What is the rotation axis? What degrees?
Does that say 23.45?
That's right, 23.45 degrees. So this is straight up and down.
Mhm.
This is about 23 degrees.
Okay.
And so the Earth is rotating on its axis. That gives us day and night. It's orbiting around the sun. That gives us the seasons. Now go ahead and go to the next picture, please.
All right.
The sun does not heat up the Earth in different spots evenly, except for near the equator.
Okay.
And you know, near the equator, it's almost always what?
Summertime.
Summertime, warmer, exactly.
Mhm.
That's the tropical area.
Mhm.
But since we live up here a little bit higher,
Right about
there
there.
you go, right in there,
Mhm.
the sun hits that area more intensely
Mhm.
from springtime through the summer to the fall.
Yes.
So as we're going around the sun,
Mhm.
it takes 365 days or 1 year to get all the way around. During that period of time, the sun is more directly heating up Illinois.
Hey.
Therefore, we get our spring and then summer season.
Nice.
Then it goes around to the other side where the Earth is actually tilted away from the sun, or
Okay.
the northern hemisphere is
Mhm.
tilted away. Therefore, it's a little bit cooler because the sun's rays are not as intense.
All right.
So here's the other way to figure this out and to get a better feel for it.
Mhm.
If you go outside on December 21st and the sun is out
Yes.
at, let's say, about noon,
Okay.
between noon and 1,
Okay.
where do you think you would look to see it? Straight up like this?
Well,
Or like out like this? I don't know if you can see my hand and my arm.
yes.
Can you? Okay.
Yes, again.
All right. So
Yeah.
we see the
So which
sun
way?
to the south.
Really? Because I was thinking noon, it's straight up.
Well, so on December 21st, what day is that for the seasons?
That's the first day of winter.
That's right, the first day of winter. So the sun is really low in the southern sky for us. Now, when we go out on June 21st,
Okay.
what's June 21st?
That's the first day of summer.
First day of summer. Now about noon, where would you look?
North? Straight up?
Straight up.
Ah. Okay.
Because the sun's going to be a lot higher.
Okay.
So during winter, the sun is all the way down here.
Mhm.
During summer, it's all the way up here.
All right.
Isn't that cool?
That is cool.
Especially during the winter, that's cool.
It's very cool.
That's funny.
You'll have to help us with the jokes of the day, Mr. Gill.
Well, you know, dad jokes, science jokes, they're all about the same.
Very cool. Did you
All
have
right,
one
so
more picture?
I
or
have
is this
one
it?
more question for you, Miss Annie.
Okay.
Name at least 3 really cool weather songs.
Weather songs.
Right off the top of your head.
Well, I immediately think of stormy weather.
All right, that's one. What's your
well-
name?
Oh, the sun will come out tomorrow.
It comes out when?
Tomorrow, yes,
Sing
from
it for-
Annie.
The sun will come out tomorrow.
Very
Bet your
nice.
bottom dollar that's tomorrow. How was that?
It was lovely. It was lovely.
All right.
And then I was thinking one of our choir favorites, which is Walking on Sunshine.
Ooh, okay.
hmm
That's
I'm walking on sunshine. Wow. That's one of our faves.
all right. Here's my other favorite one.
All right.
Beatles.
Yes.
Here comes the sun. Doo doo doo. Here comes the sun.
And
I
I
say, It's
It's all right. That is also one of our
Better.
faves. It's a good one.
Science and music go hand in hand.
They do.
This is fun.
Excellent. It is. All right. Well, Mr. Gill, this has been wonderful. We would like you to come back sometime for some other science too.
All right. That'll
Would
be
you help
great.
us out? Awesome. Well, thank you so much for answering our weather-related questions and helping us out this week with Weather Week.
You're welcome. And everyone
Yes.
have a great day. We'll see you all soon.
Thanks. Bye.
Bye.